So here is another question on linear inequation in one variable. So it is given, solve the following linear inequation given by 30 minus 2 into 3x minus 4 is lesser than 24 with x belonging to whole numbers, the replacement set. So we have to plot the solution on the number line. Okay. So first let us solve the inequation. So 30 minus 2 into 3x minus 4 is lesser than 24. Okay, so that implies 30 minus 6x plus 8 is lesser than 24. Okay, minus 2 into 3x, that is minus 6x, minus 2 into minus 4, that is plus. Now we'll take this 6x to the other side, so we'll hand this 24 to the LHS. So 30 plus 8 minus 24 is lesser than 6x. Okay, that implies 38 minus 24, that is 14, is lesser than 6x. That implies 6x is greater than 14. That implies if we divide both sides by 6, the sign of inequality will stays the same. X greater than 14 by 6, which is equal to 7 by 3, or x is greater than 2.33, and so on, will go on. So this is the solution. Now the replacement set, the choice of numbers from which we have to pick the solution set, it is the whole numbers, that is the whole numbers 0, 1, 2, 3, 4, 5 and so on. It goes on and on. Okay, so here what we have to do, we have to pick only those values which satisfy this criteria. Okay, specified criteria. So anything greater than 2.33, but as we have only distinct numbers here, whole numbers, no decimal values, so we have to pick only those distinct numbers which are greater than 2.33, the whole numbers. Okay, so it means anything greater than, starting from 3, everything is applicable here. Okay, starting from 3, everything is applicable here up to infinity. So the solution set is 3, 4, 5, 6, 7, 8 and so on up to infinity. As far as the number line goes, only the whole numbers, okay, distinct numbers, distinct points, therefore, with no fractional or decimal values involved. So if we have to plot it on the number line, we'll have okay, so let's say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. So likewise it will go on and on. So we'll highlight it as this, 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 and we'll then place a arrowhead. It will goes on and on and on like that towards the right hand side. So this is how we plot the solution on the number line. Okay, so this arrowhead, it indicates that it goes on and on in a similar manner as far as the number line goes, because the solution set is applicable for all the numbers greater than 2. I mean, it's as per the solution it is 2.33, but 2.33 is not applicable for this replacement set. So starting from 3, everything is included in the solution. Okay. So here is another question on linear inequation in one variable. So it is given to solve the following linear inequation, which is given by 3 by 5x or 3x by 5 minus 2x minus 1 by 3 is greater than 1, with x belonging to the integers, the replacement set. And we have to plot the solution on the number line. So first we have to solve the inequation. 3 by 5x minus 2x minus 1 by 3 is greater than 1. So here we'll take this minus 2x minus 1 by 3 to the RHS, it will become plus, implies 3 by 5x is greater than 1 plus 2x minus 1 by 3. Okay, so the sign of inequality, it will stay the same, that implies 3 by 5x is greater than, here 3 plus 2x minus 1, that implies 3 by 5x is greater than 2x plus 2 by 3. Here you can either do cross multiplication or you can multiply both sides with the LCM of 3 and 5, which is 15. Either way you will get the same result. So if we multiply both sides with the LCM of 3 and 5, which are in the denominator on either side, we'll have here 15 multiplied here and 15 also multiplied here this side. So here we have 3, here we have 5. So if we had done cross multiplication also, we would have got the same result. That implies 9x is greater than 10x plus 10. Okay, 5 multiplied with 2x plus 2, 3 multiplied with 3x. That implies 9x will take this 10x to the LHS side, will become minus 9x minus 10x is greater than 10. That implies minus x is greater than 10. So here, if you remember, we discussed in the rules of handling the linear inequations. Suppose the sign on either side of the inequation, the LHS and the RHS, it is changed. Okay, then the sign of inequality, it reverses. So here, if we suppose change the LHS sign minus x to plus x and this 10 on the RHS side to minus, the sign of inequality will reverse. X is lesser than minus 10. So this is the solution of the given inequation. Now the replacement set is the integers, on either side up to infinity, negative infinity to positive, then it carries the whole thing. So here we have to pick only those values which satisfy this criteria, lesser than minus 10. So here obviously it means, if we draw it on the number line, okay, we'll start from here minus 10, then minus 11, minus 12, minus 13, minus 14, minus 15, and on and on and on. So here lesser than minus 10. So these are integers with no decimal or fractional values involved here. So these values -11, starting from -11, -12, -13, -14, -15, -16, like that it will go on and on and on. So we'll place an arrowhead like this pointing to the left hand side. So it goes as far as the number line goes, okay, with these integer values starting from -11, and it goes just like that. Okay, so this is the solution in the number line, and the solution set we can write it as -11, -12, -13, -14, -15, and just like that goes. Okay, so this is the solution.